Okay, so before you realize that you don't want to spend an hour watching this video, let me just tell you that you might actually need the 5 first minutes. So we're gonna go and do an overview of what multiplayer is and how it works, and then we'll go inside of the engine and actually apply it. We will be hosting directly on our machine, but it's a simple standalone application, so if you want to port it over to a Linux somewhere or any other computer really, you just open the IP and you connect through there. That is super easy to do with Unity. And also for the clients, we'll be using web browser, so we're going to be connecting through Chrome, we're going to be connecting through really anything. We can also use a standalone app if you want, but I wanted to do web browsers so we can actually do web sockets as well. That might actually be something that interests you. For me, I'd like to create some kind of multiplayer game on the web so people can simply connect, and it's way easier to test that way because I can just open multiple tabs on my browser instead of opening multiple applications. Okay, so if at any time during the video you feel like you've made a click, you feel like you actually understood how the protocol works, I really encourage you to go and try it out, as it is going to lock in the information in your brain and you'll be one step closer to creating that multiplayer game you want. Alright guys, let's get started. Unity's multiplayer, or UNET if you prefer, is actually done using socket. And when you have the socket, you create open connection in between the client and the game. This connection has to be maintained, so you can actually just try and cut it, or you cannot have just a power outage and stay connected. You really have to stay connected in between the client and the game at all time. Now, of course, you can get disconnected for a while and then try to connect back. You can have an application that does that, but really the main goal is to maintain that connection and have a constant flow of data transferred in between the client and also the server. With this type of multiplayer, you can create synchronized games such as a racing game, a MMO, a MOBA, really any kind of game where you can see player move basically and have instant action on them. On the other end, if you want to create something more async such as Pokemon Go, you would go with a web server option instead. So it's simply you send requests when you need them, and in Pokemon Go it's something like every 10 seconds the player asks, okay, so is there something around me? And then the server gives him back a response, yes, there is this Pokemon here, this Pokemon there. So in these type of game, they talk to each other when they need to, and every time they create a new request, and then they have a response. We're not going to go through that. Actually, if you want to go through that, we have a Pokemon Go class coming up sometime this year. You just have to follow the channel, follow the Facebook page, I'll post about it there. But this is not a type of game we're going to be making today. We're going to be creating a synchronized game. When using UNET, you will quickly realize that it has been built in such a way that allows you to do peer-to-peer, which means that everybody that runs your game could potentially become a server as well, so they can receive data from other and they can send back as their own. But don't worry, if you need a client-server architecture, you can also do that, but having the perk to transform your client into a server later on is always a cool thing. Alright, so if you have a look at Unity's documentation under multiplayer, you will find out that you've got two different approaches. You've got a high-level approach that uses component in Unity, so component that Unity has to offer, or you can take a low-level approach, which is more complex, but also gives you way more flexibility. It doesn't restrain you to do, it doesn't restrain you the same way as the high-level one does. And if your goal is to learn, actually, how to make a multiplayer game, I would really suggest taking a low-level approach, as it is going to be useful outside of Unity as well, while the high-level one is only going to work in Unity basically because you're using Unity's component. You'll also understand better the restriction you have when you make a multiplayer game if you take the low-level approach. And if that didn't convince you, I'm really sorry to announce to you that today we're going to be using the low-level API, or it's also called the Net Transfer API for Unity. And we'll create everything from scratch. It's gonna be like the multiplayer checkers tutorial. It's really the same. We're using socket and we're just sending data back and forth. But however, and if that didn't convince you, I'm really sorry to announce to you that we're not gonna be using the high-level API. We're gonna be using the low-level one. Because why would you be using the high-level one? You can't use it anywhere else than Unity. And you're here to learn, right? You're on the channel to learn. But don't worry though, it's not really that complicated. Alright, for the low-level API, the first thing you'll need to do, and that's for both client and server, is to initiate the transport layer. You will define how many people can connect to you, and also what type of communication channel you'll be using. Channels are basically ways to deliver your messages. They are reliable channel, unreliable, fragmented, and if you're not familiar with this, just ask yourself, does the receiver really needs that information? For example, if your client does a transaction involving in-game currency or like real money, you'll want to send that message on a reliable channel, so you're making sure that the message actually gets sent and gets received. It's a message that you cannot afford to lose, else you might get charged twice or other weird behavior if the message is lost along the way, so you really need this to be on a reliable channel. An unreliable example would be for the player's position. If the connection has some hiccups, you can afford to lose some position update from time to time, because there's always going to be position update every single frame when your connection is back to a more stable state basically, so those are always going to be overridden. We'll talk more about the channel when we create the example. So you've defined which channel you want to be using, how many people can connect to you. The next step is going to be to create a host, and that is something that might sound weird, but you have to do on both the client and the server itself, so you got to be creating hosts on both sides. Always keep in mind that the client can be turned into a server later on. Once you have that network layer, this is where you'll be taking two different paths based on if you're the client or if you're the host. The client will connect using a simple line of code, while the server will just wait for a connection and wait for messages. No additional line required. But in our case, we're going to add one more line to that server. We're actually going to open another socket to include the web sockets. And that's it. At that point, you have your client and you have your server. They're both hosts, but one of them, the client, is connecting to the server, so at that point they're connected that way. What you're going to be needing to do next, what's the next step, is you're going to have to check every single frame on both hands. You have to check on both hands, is there any messages? So did this client send me a message, or did this server send me a message? So you have to check every single frame on both sides if you have any messages. This can be done in a simple update function on both client and also server. There is only 4 types of messages you can receive on both ends. The first type is nothing, which means there is no message right now, so let's not bother doing anything else. The second one is connected, so somebody just connected to me. Third one is data. This is where everything's going to happen. We'll go more in depth really soon. And fourth one is disconnect. So basically somebody's disconnecting to me and now I have to remove him off my list of players or stuff like that basically. Now the really important one is just data really. Of course you're going to be connecting people and disconnecting them as they come and go in your game. But where your logic is going to happen, where you're actually going to have your gameplay and the whole multiplayer logic is going to happen in data. So let's say that player 1 wants to do a spinning attack or something like that. He's going to have to tell that to the server, and then the server is going to have access to everybody else. So the server has a list of connected player. What he's going to do once he receives that message from player 1, he's going to redistribute it to everybody else. So he's going to say, okay, everybody, player 1 is doing a spinning attack. And then just like that, everybody else can be in sync and have this spinning attack on their hand. Now, of course, if this is not clear to you, I just really encourage you to stay around. We're going to create an example like that in the future game that we're about to make. But yeah, that's really it for the big picture explanation. We're going to jump into the actual engine and start creating a server, a client, just have them communicating. I'll show you what kind of code I use, what kind of approach I have towards this, and we can start having these two things communicate. So guys, let's get right into it. Alright guys, so we've got a fresh project right here I'm about to create, and we're going to just jump into the multiplayer system and try to establish something that is quite simple. I don't have any games in mind. I simply want to have the player tell its name and then connect into a world where other people are there, and you know, they can just move and we update the movement position just to tell everybody that there's other people around you and they can also move. So basic multiplayer stuff. And we are going to get started right away. I'm going to try and do my best to not get interrupted too much. I do have a code here to look at, so before I made this video I actually have like some kind of reference, and I'll try to go over it as quickly and as clearly as I can. So whenever you create a new project, you always set up the folders. Let's start with a script folder, a scene folder, and also I'd like to do a prefab folder in this case, since we'll be holding a player prefab. Alright, so the next thing I will be doing, let's actually start by making the client scene. I like to just quickly make a client scene, and then it's going to take like about 2 minutes, then we'll jump into making the server, because that's really what we're here for. But we need to actually have something first, so I'm going to save this scene as client, put it inside of the scene folder. I'll right click, create a new empty game object. That's going to be, say, the client object, and on top of it I'll add a client script. Now that's pretty much all the setup we need for this. We also need a player prefab, which I will put in here really shortly. But before that, let's hit Control and N, server, and do the exact same thing, but for a server scene this time. So create an empty game object, that's going to be the server object. On top of the server object, there is going to be the server component. And we are going to open up these scripts inside of Visual Studio. So we're going to start, actually I said we're going to start with the client. That's a bit lie. Let's actually start with the server, because that makes more sense. You need to have something you connect to as a client. So the server is the first thing you need to start tackling. And so what's going to happen here is I'm going to open both server and also client. And we'll do the, there's like a part at the beginning when we instantiate the network transport layer that it's basically the same exact thing, so we'll just copy on both sides. So on the server here, we'll start by declaring a few fields at the top. Let's start with a private const int max connection. That's of course how many connection can be connected to your hosting, so your computer, and that goes for both client and server. And just after that, I'll be using a port, so private int port. Oh, by the way, whenever I have a constant like this, I always put it in all caps, because that's how I declare my constant. So we have a port. We do not need the ID because, well, we don't need the IP address, because the server is itself, basically. You're not connecting to anybody else but yourself. So in this case, server doesn't need that. We need a private int host ID, which we'll use later on. Private int web host ID, which is really interesting. Actually, it is for WebSocket server. And then private int reliable channel, private int unreliable channel, and I'll get more details as soon as we reach this point in the code. And then a private bool is started to know if we are started. Finally, private byte error. So these are the fields I actually need for both the server and also the client. So I'll take these and I'll copy them over on the client as well. Now we are going to start by instantiating initializing the network transport layer, and this will be done in a start. So as soon as the server is started, as soon as the server scene is ran, we want to do network transport. So network transport, and to actually use that, we'll have to do using Unity engine.networking. So make sure you include this at the very top. Network transport.init, and that's pretty much the only thing we need to do to initiate this. And then we need to get into configuring that transport layer. So connection config, I'll call CC, is equal to a new connection config. And then at this point, we are going to start declaring what type of channels we're going to be using for communication. And this part is a little bit hard to understand when you just start with multiplayer, but basically, when you have a connection between a server and a client, you can define, well, in this case, in the UNET case, you can define which type of message, how you're going to be sending that message. So right now we have two channels at the top. We have the reliable channel and the unreliable channel, and I probably pronounced that really bad. Don't worry about this. Reliable basically means that your message is going to be sent and it's going to be received 100%. So you're making sure that it is sent and it's being received in the same order as it being sent and received, basically. If it's unreliable, it's going to be sent, but it might get lost along the way. So you need to actually make sure that if you're doing something important, such as a transaction or a connection, that your message has to be sent and received. If you're updating the position of your player, that does not have to be received. It has to be sent, of course, but it doesn't really have to be received, because on next frame it's going to be sent again. So if you have some kind of hiccups during the communication in between the client and the server, it's not that big of a deal if you lose some position update, because they keep being overridden every single frame or every single update loop. So that doesn't have to be reliable. That is a lot less costly. So on the server side, it's not going to be that expensive to actually send that message. And if it is actually being received, then well, that's a good thing. And if we have a hiccup, it's not being received. We're going to see like a small lag spike in the game, and eventually it's going to go back to normal. So to add these channel in the UNET, it's really easy. Let's actually use our reliable channel in and say it's equal to cc add channel, and then you have the option. So we want to be adding a reliable channel in our case for important information, and unreliable channel for movement updates. So add channel unreliable. There's also other channels such as reliable fragmented, so that's for big chunks of data when you have to send